Hello again, everyone. So today I will be discussing some more maxima minima problem. So this will be the part two, following the last video that I uploaded. So I highly encourage you, or I highly suggest that you also watch the video that I last uploaded. Okay, so going into the problem. So number one, we have a rectangle is inscribed in an equilateral triangle of side 20. So what is the highest possible area of the rectangle? So we have here the possible highest area. Okay. So therefore the area of the rectangle must be maximized. But first we have an equilateral triangle of side 20. When you say equilateral triangle, all sides are equal. So if we have here an equilateral triangle, let's say this is the triangle. So we'll have here a rectangle inside. So let's say this is the rectangle. Now, if that is the rectangle, therefore from here to here, that will be your width. That is the width of the, this is the width of the rectangle. Okay. And of course, from here to here, that is the length or the height of the rectangle. From here, this is your height. Okay. Or I think it's better if we will use length. Let's just use length. Okay, so this is your length. Okay, so going into the dimensions or the dimensions of the triangle, of course, from here to here, since that is an equilateral triangle, we all have the same, all sides are equal. So from here, that is 20. Okay. This is also 20. Now from here to here, so that will become, that is now the height of the triangle, right? That is from here to here. That is the height of the triangle. So let's say this is h, small h. Okay. So if this is h, this is your length of the triangle. Therefore, from this part will be h minus l. This is h minus the length. Since this whole from here to here, that's h, and this is l. Therefore, this part we can also say that this is the height minus the length of the triangle. Okay. So now we have to. We can now write the area of the rectangle. Of course, the area of the rectangle is just length times width. So area of the rectangle will be length times width. But again, remember that we have to maximize this, or again, what is asked is what is the highest possible area of the rectangle. Therefore, this formula we have to maximize. I'll just put here max. Okay. Okay, so what we will do is, as you can see, we can now let's find first the height. Let's find first the height. So the height, using this part of the triangle, this one, this is your height, right? And if I will use this part of the triangle, this and this one, okay, I'll just redraw it here. So this is triangle, and since that is an equilateral triangle, that means this side is also 20. So this is also 20, and this will be your height. Okay, and this part, since it from here to here, it will be able to cut the 20 in half. Therefore, this must be only 10. Okay, so from that we can use Pythagorean theorem, right? Pythagorean theorem, use PT to find the value of height or the h. Therefore, using that, you'll have h squared plus 10 squared. That must be all equal to the square of the hypotenuse, which is 20 squared. As you can see, this is a right triangle. So h now will be equal to, let me just get my calculator. So h now will be equal to, that's square root of 20 squared. Square root of 20 squared minus 10 squared. That's 17.32. I think we can, that will become square root of, let me just write it, 20 squared minus 10 squared. This is all equal to square root of 20 squared minus 10 squared. That is 10 square root of 3. So this will become 10 square root of 3. Okay, so that is your height. Now, using now ratio and proportion or similar triangles, we can use similar triangle. Okay? Because if we have to um, maximize this, the area is equal to length times width, we have to be able to express this equation into one variable only. So as of now, it is in two variables, which is the length and width. Therefore, we must be able to uh, express this equation into only length, terms only in length, or equation containing only width. So we must be able to eliminate either the length or width. So using similar triangles, as you can see, we can use this triangle. Sorry, this triangle, and then this. That's the first triangle, okay? That's the first triangle, and the second triangle, let's say it will be the big one, okay? The original triangle. This triangle. Okay? So using first the small triangle, okay? Your base of that, this one, the length of this one is also the width. So the bottom part will be your width, and the height, okay? And the height of that, okay? The height of this small triangle is h minus l. That is h minus l. Okay? Now going for the big triangle. Going for the big triangle. Okay. The big triangle, you'll have the bottom part or the base of the triangle will be this one, 20. 20. And the height will be, of course, the height itself. Okay, the height. So using similar triangles, we can use height to base. Okay, height to base. So that is height into base. We can also call this ratio and proportion. Height into base. So what will happen is height of the small triangle into height of the big triangle, which is h minus l all over. That's the height of the small triangle into the height of the big triangle, which is h. Now this will be equal to, let me just, this is 20, okay? This is 20. Base of the small, which is width, and the base of the big one, of the big triangle, is 20. Okay, so let's isolate width. So isolating width, you'll have width is equal to, okay, 20 times h minus l all over h. Okay, if I will isolate this h, I will split h minus l into all over h. That will become 20 equal to, you'll have here h over h, that is 1, minus the length over the height. But we already have the value for h. Therefore, we can say that the width now will be equal to 20 times 1 minus length over 10 square root of 3. Square root of 3. Okay, so let's say this is our equation 1. And of course, what we will do here is substitute to equation 1. Let's substitute this. Substitute to 1. Okay, so we will have to substitute this here. So substituting that, you'll have area now will now become equal to length, and your width will be replaced by this one, that is 20 times 1 minus length over 10 square root of 3. Okay, so distributing 20 and L at the same time, you'll now have that will become times 1, that's 20L, minus now 20L over 10 square root of 3. Oh, this must be squared. L squared. Okay. So this is also equal to 20L minus, that's 20 over 10. You'll just have 2L squared all over square root of 3. Now we were able to express the area into one variable only, which is L. Now we can now differentiate or perform the first derivative in this equation. So performing first derivative, that will become dA over dl, that's derivative of the area with respect to the length. This is equal to derivative of 20L is just 20 minus power rule. So 2 will go down. That will become now 2 times 2 is 4, or over all over L all over square root of 3. And we all know that this must be equal to 0 to get the maximum value for the length. So from this equation now, solve for L, or solve for the length of the triangle. So transpose 4L over square root of 3 into the other side. So you'll have 4L over square root of 3. This must be equal to 20. Therefore, length now, the value of length now will be 20 square root of 3 all over 4, or this is just 5. Okay, 5 square root of 3. Now this is your length. So you already have the length, and now substitute this value, the 5 square root of 3, into to get the width here. So substituting that, you'll have your width now will be equal to 20 times 1 minus your length now is 5 over square root of 3. So that's 5 square root of 3 over 10 square root of 3. So now we can cancel square root of 3, and 5 over 10 is just 1/2. Therefore, we can say that the width now is just equal to 20 times 1 minus 1/2. Therefore, 1 minus 1/2 is just 1/2, and 1/2 times 20 is just 10. Therefore, we already have the value for width, which is 10, and we already have value for the length, which is 5 square root of 3. Therefore, getting the area, which is length times width, can just take the value of L, or the length, 5 square root of 3 times 10. So the final answer will be just 50 square root of 3. That is your maximum area of the rectangle. Okay. Okay, so for a shortcut, of course, we have a shortcut. So the shortcut now will be, let's just write for the shortcut. For simpler solution, okay. Shortcut. The area of the rectangle, it will be equal to square root of 3 over 8 and multiply it by the a squared, where a is the side length or the length of the triangle. Okay, so this is the length of side length of the triangle. Okay, triangle. Therefore, applying this formula or shortcut, a here will be equal to 20. It's already given. Here it's 20. Therefore, if you get the area using the shortcut formula, you'll just have square root of 3 over 8 times 20 squared. And if you will simplify that using your calculator or what, you will also arrive at the same answer, which is 50 square root of 3. Okay. Now, if you want to find, if let's just erase this one. Erase. So if you're asked now to find the length and the width of the triangle, the length is just square root of 3 over 4a, while the width is equal to a over 2. So if you will apply those to this example, your length will be square root of 3 over 4 times 20. And then 20 over 4 is just 5. That means the answer is 5 square root of 3. Okay? While the width is just a over 2 or 20 over 2, which is 10. Okay? And as you can see, we also got the same answer here. This is your length, which is 5 square root of 3, and this is your width, which is 10. This one. Okay, so let's go to the next problem. Okay, so for the next problem number 2, we have find the dimensions of the rectangle of largest area whose base is in the x-axis and whose upper two vertices lie on the parabola y equal to 12 minus x squared. What is the maximum area? So we are asked to find what is the maximum area of the rectangle. So the first step you must do here is we have to know what type of parabola is this. So we have here a parabola. So y equal to 12 minus x squared. So all we have to do is let's try to reduce this to its standard equation. So transpose x squared and then transpose y. Therefore, you'll have x squared equal to 12 then transpose y. That will become negative y. So x squared now, let's factor out here negative 1. So factoring out negative, I will not put the 1. So you'll have here 12 minus, oh no, sorry. This must be y minus 12. Okay. So now we can now see that since the x is squared, the opening of this parabola must be either upward or downward. But since this is negative, therefore the opening of this parabola is downward. Opening is downward, okay? And the vertex of this parabola now will be, since x squared doesn't have any variable with it, 0. and negative 12. So negative 12 must the sign must be changed. Therefore, the 0 to 12. Okay, so let's try to graph this one. So graphing this one, you'll have, let's say this is the x-axis. I'm sorry, this is the y-axis. Okay, and this will be your, of course, your x-axis. Okay, and then let's try to put the parabola. So let's say that this part will be 12. I think parabola looks something like this. There you go. And we just need a parabola. So let's say we have to delete this one. Okay. So that will be the parabola. Okay, so if that is the parabola, therefore, this part is your 12. Okay. No, let's just put the coordinates. So putting the coordinates, that means this is 0, 12. This is 0, 12. Now for the rectangle, where should I put the rectangle? So as you can see, the basis of the basis of the rectangle must be in the x-axis. Okay, so the basis must be in the x-axis. Yung base must be in the x-axis. So and the other two upper vertices, this one must touch the parabola. So therefore, the upper two vertices of the rectangle, they will be the intersection of the parabola and the rectangle itself. So it will look like something like this. Oops. If this is a rectangle, there you go. So as you can see, this point will be the intersection that these two upper vertices of the rectangle is touching the parabola, while the lower vertices or the base of the rectangle is on the x-axis. Okay, so going back to the problem, therefore, if that is the case, let's say that this point will be your this point. If this point, okay, this point, let's say this point is x, y. Okay, if that point is x, y, therefore, from here to here, that will be your x, and this part will be y. Therefore, if this is x, therefore this is also x. The length of this side is also x. Therefore, from here to here, that is the width of the rectangle. That is the width of the rectangle. And this y will also be your length of the rectangle. So if you want to find the area of the rectangle, so the area now of the rectangle will be, of course, we have here length times width. But now the length here is equal to this one, y. And your width now will be x plus x. Therefore, your width must be equal to 2x. 2x. Okay, so substituting those values, you'll get your area now will be equal to 2xy. Okay? And again, we have a equation for the parabola, which is y equal to 12 minus x squared. All you have to do is this one. Let's say this is our equation 1, and this must be maximum, right? This must be maximum. So this must be max. This one, substitute to equation 1. Substitute to equation 1. Therefore, you'll have, substituting that, you'll have a equal to 2x times this one. That you'll have 12 minus x squared. That will be the value for your y. And now, distribute. You'll have here 24x minus 2x cube. So as you can see, we are now able to again express the area into one variable only, which is x. So now we can perform now derivative. So of course that will be the derivative of a is dA. So derivative of the area with respect to x. That's dA over dx. This is equal to 24x. Derivative of 24x is just 24 minus power rule. 3 will go down. So 3 times 2, that will become 6x squared. So again, in order to maximize this function, you'll have here, this must be equal to 0. Okay, so finding x or solve x. So solving for the value of x here, 6x squared must be equal to 24. And then, of course, x squared now will be equal to 24 over 6, that is 4. And x now will be square root of 4, that is plus or minus 2. Okay? Now we already have the value for x. Let's try to get now the value for y. All you have to do is substitute the value of x. Okay? So again, remember that y is equal to 12 minus x squared. Okay? 12 minus x squared. But we already know the value for x squared, which is this one. X squared equal to 4. Therefore, this will be equal to 12 minus 4. So y is just equal to 8. So we have the value for y, and we already have the value for x. Of course, we have to use the positive value. Again, recalling, we have to get the maximum area. So a equal to 2x y. And this will become equal to 2. Value of x is equal to positive 2. Positive 2 times 4. Oh, no, sorry. It's 8, not 4. 8. 8. Therefore, the answer is, that's 8 times 2. 8 times 4, that's 32. That will become 32 square units. Okay, so let's go to the next problem. Okay, so for number 3, in the museum, a painting is hanging on a wall. So the bottom of the painting is 6 feet above the floor. Considering that your eyes are 5 feet from the floor and the painting is 3 feet in height, how far should you stand from the wall in order for you to have the best viewing angle of the painting? Okay, so this problem is quite hard to imagine, but I'll try my best to explain. So let's just draw the figure first. So drawing the figure first, you will have, let's say that this line will be your floor, okay? So if this is your floor, I'll just use red. Let's say this is your floor. Okay, so this is the floor. Next, the bottom of the painting is 6 feet above the floor. Okay, so let's try to draw the painting. So let's say that this is the wall. Okay, so this is the wall, and it must be, nope, 6 feet. The painting must be 6 feet above the floor. So let's say if this is the painting, it must be 6 feet. Okay, let's say that this is the painting, and let's try to color this one. Okay, let's try to color this one. So this will be your painting. Okay, so this is the painting. Okay, so that must be 6 feet. So from here to here, so this is the bottom of the painting and this is the floor. this must be this one, 6 feet. So this must be 6. Next, considering that your eyes are 5 feet from the floor, and of course you have to consider that you are standing away from the wall or from the painting. So let's say that your eye level must be 5 feet. So it must be 5 feet. So let's say this is your eye level, okay? If this is your eye level, oops, let's say this is your eye level, okay? This is your eye level, this part. Considering that your eyes are 5 feet from the floor, therefore, from here to here, this will be 5 feet, right? This is 5 feet. Next, okay. And the painting is 3 feet in height. The painting is 3 feet in height. Therefore, this is the painting from here and to here. This is must be 3. The height of the painting is 3. Okay, so how far should you stand from the wall in order to have the best viewing angle? So if this is your eye level, of course, this is also you. You must stand from you are standing from the distance. You have a distance from the wall or to the painting. And that is what we are looking for. How far? Okay, so this will be your X. Okay, there you go. So that is your X. Okay, so all you have to do is, if I will try, I have to consider that we are asked to find the best viewing angle. Okay, if I will connect, so this is your eye level. Okay, so eye level from here from to the top of the painting, and here to the bottom of the painting. Okay, so I will just try to connect another line, a straight line here. Okay, so just a straight line. Okay, so what will happen here is, if I will say that this part, let's just say this angle is omega. Okay, let's say this is omega, and this angle will be your, let's say this is your alpha. Okay, and this is your alpha, and let's say that this big angle, let's say that this is your beta. So you have to think that which one of this angle must be maximized in order for you to have the best viewing angle. Of course, the angle that looks directly to the painting, which is the alpha, right? This is your eye level. Of course, you have to focus on the painting. So looking at these eye levels from the bottom of the painting to the top of the painting. So alpha must be maximized. So from this, you have beta, alpha, and omega. Okay, so let's try to solve for this one. So of course, from the angles given here or from the figure, it's obviously that your beta must be equal to alpha plus omega, right? But alpha must be maximized. Therefore, we have to isolate. We have, we have to isolate alpha. So isolating alpha, you'll just have beta minus omega. And then this part, you have to maximize this one. Max or minimum, whatever. Okay. Then again, you have here two variables, so beta and omega. So again, you have to be able to express this equation into one a variable only. So we can use this triangle. So using this triangle, okay, the big triangle, this one. Okay, so that big triangle, okay, let's just try to rotate this one. Okay, that big triangle will be the angle of this one will be beta, the big triangle. Okay, so this one, that will be, and your bottom or the base of the triangle will be this one, of course, is x. So this is x. And what is the length of this side? Okay, this side. As you can see, this is 3, and we have to still add this one, this part. So adding that one, again, this is 6, and this is 5. Therefore, from here to here, that is obviously 1. Therefore, that's 3 plus 4. This part is 4. Okay? So using, obviously, this is a right triangle. All you have to do is use SOHCAHTOA. So that is opposite over adjacent. Therefore, that is tangent beta must be equal to 4 over x. Or beta is equal to arctan of 4 over x. Okay, let's say that this is your equation 1, okay? Now, for the omega, all we have to do is consider now, let's try to consider this triangle, okay? This triangle. So considering the triangle, you'll now see, okay, let's rotate that horizontal. Okay, therefore that's 1 and the base is x. This is, oops, this is 1 and the base is x. And then, what is this angle? It will be omega. So again, using that is opposite over adjacent again, you'll have here tangent omega equal to 1 over x. And then omega must be equal to arctan of 1 over x. 1 over x. Then all you have to do is this one and this one, substitute to equation 1. Substitute that to equation 1. Okay, so substituting it here. So substituting that, you'll have now the alpha will be equal to, your beta is arctan, okay, or inverse tan, times 4 over x. Okay, that's your beta. Minus now is arctan of 1 over x. 1 over x. Now again, remember that you have to maximize this or minimize. Okay, then let's just fix this one. That's tangent. Okay, and then you have to maximize this. And as you can see, we only have one variable. We are able to again to express this equation into one variable, which is x. So we have to, let's just do a quick recall. Okay, let's do a quick recall. What is the derivative of those? Again, if you will recall, the derivative of tangent arctan u, that will be equal to, that must be du over 1 plus u squared. Okay? Alright, so getting the derivative of this function, okay, getting the derivative of the function, you'll have d of the alpha of that angle over with respect to x, which is dx. This will be equal to, remember, du, your u here will be 4 over x. Therefore, I'll just try. If your u here is 4 over x, therefore your du will be what? That is quotient rule. That will be negative 4 over x squared. Okay, so let's try to use this one. And while if your u now will be, for this part is 1 over x, your du now, again using quotient rule, you will get here negative 1 over x squared. Okay, so substituting those, you'll have du over 1 plus u squared. So for the arctan of 4 over x, you'll get your du is negative 4. Ito, negative 4 over x squared. Therefore, your du is negative 4 over x squared. And then 1 plus u squared. Your u is 4 over x. 4 over x. Don't forget the u. Okay. Minus now. Minus, that's du. Your du now is negative 1 over x squared. And then 1 plus 1 over x. So 1 over x squared. So as you can see again, we have to maximize or minimize this function. This must be all equal to 0. Now, all you have to do, I won't show it anymore, is all you have to do here is solve for x. And then if you will solve for x here, the answer will be x equal to 2. Okay, so this must be 2, or that is must be in feet, so 2 feet. That's the answer. Okay, so going for the shortcut, of course we have a shortcut, and you can really say that this one is really a shortcut because not all of us can remember the derivative of arctan or any other inverse trigonometric function. Now, going for that, remember that our answer is 2. I will just delete this one. Okay, and then this one too. The shortcut for this one is, let's try to do the shortcut. The shortcut will be x is equal to, this is really easy to remember, square root of a b. Now what is a b? What are a and b? Remember that the a is the distance from the eye level to the bottom of the painting, and b is the distance from eye level to the top of the painting. Okay, therefore if I will just erase these writings, okay, just erase this. Remember that this one is 1, right? This is 1, and from the height of the painting is simply 3. Okay, so the value of a, I will just make it a red. The value of a, that is from eye level to the bottom of the painting, which is here. So this is the value for your a. That will be your a. And the value of b will be from the eye level going to the top of the painting. So this is your eye level to the top of the painting, which is here. This will be your b. So using these values, therefore your a will be equal to what? This one, 1. And your b is equal to, of course, from here to here, that will be 3 plus 1, which is 4. So using the formula of this one, now x will be equal to the square root of ab. A is equal to 1 and b is equal to 4. So that's 1 times 4, that's 4. Square root of 4 is just x equal to 2. And that is how easy to solve this problem. Okay, so on to the next problem. Okay, so for the last problem, I will add just one problem for related rates, or you can also call this time rates. Um, because this problem is quite common or popular or a usual problem for time rates. Okay, so a stone is thrown into a still pond and causes the water to create multiple circles. The radius of the multiple circles increases at the rate of 12 inches per second. So at what rate is the area of the multiple circles increasing when its radius is 3 inches? So what will happen here is, let's say there's a pond. Okay, let's say this is the pond. Okay. Of course, it contains a water. So what do you mean here by still pond is the pond, there's no any movement on the water surface. Okay. And then suddenly a stone is thrown into the pond. So what will happen if, let's say, a stone is thrown, let's say, in the middle. Okay. So in the middle. So if a stone will be in the middle, so what will happen here is it will create in the water surface, multiple circles or water ripples, what you call it. Okay. So let's say that it will cause and it will go farther away from the center or where you thrown the where you throw the stone. So what will happen here? You will have a circle here, there. So somehow it looked like something like that. Okay. So as you can see, the circle gets bigger and bigger, and the radius of the multiple circle increases at the rate of 12 inches. Okay. So what will happen here is, since we are given, so the radius of the multiple circles increases at the rate of 12 inches per second. So that is the rate of the radius. Therefore, therefore we can say that the 12 inches per second, let's try to give here or just write here the given. Okay. So here's the given um, rate of radius. Therefore, that is, let's say that's dr over dt, and that is equal to 12 inches per second. So what else is given? At what rate is the area of the multiple circles increasing when its radius is 3 inches? Okay, therefore we are required now to find, we are required to find what is the rate, is the area, at what rate is the area of the multiple circles. So rate of the area, therefore that is rate of area, that is dA over dt. Okay. When is radius at 3 inches, therefore at r equal to 3 inches. Okay, so for the solution, for the solution, all you have to do here is, therefore, in order for us to get dA over dt, we have to perform the first derivative on the area. If that is a circle, of course, the area of a circle is just simply, we all know this, pi r squared. Okay, performing the first derivative, of course, the derivative of a is dA with respect to time, which is dA over dt, equal to derivative of this with respect to r, that is 2 pi r. Okay, don't forget the dr over dt. Now all we have to do, we are now asked to find dA over dt. Therefore, this is equal to 2 pi, and then your r is 3. Therefore, this is equal to 3. And then dr over dt is also given, which is 12. Therefore, this is 12 times 2, that's 24, times 3, that is 72 pi. Is that right? 72? That's 6 times 12. Yeah, that's right. That's 72 pi. Since this is area, this must be inch squared per second. So that's the answer. Okay, I think that's all for this video, and don't forget to subscribe and subscribe to my YouTube channel, and of course hit that bell notification for more. And thank you for watching, and I see you on the next one. Bye.